Alright guys, this is an answer session for question number 2. So we have converging lenses of focal length 1.25 centimeter and 5 centimeter to design a compound microscope, and the question is to get an final magnification of 30, and we need to find the separation between the objective and eyepiece. That means we need to determine the L value, right? So when we need to do a very simple calculation, we just think of the magnification formula. There is here it's not specified like the final image is forming at infinity or a final image is forming at a near point like that. So we just take whatever the formula we remain in our mind, right? So here I have taken m equals L by f naught 1 plus d by fe. So this formula is for image forming at a near point. So then I have m value 30, f value 1.25, d 25, fe 5. So rearranging this for L and substituting it, we'll get 6.25 centimeter, and the answer what we got is an approximated answer, and we can't rely on this answer. It's not a very correct thing. Why? In the sense, in the main formula we have L and f naught. These L and f naught are the approximations of v naught and u naught actually. So when we need to find the L value very exactly, then we need to rethink our L answer, right? So L formula is actually V naught plus UE at a condition when an final image is forming at a near point, right? So if you are thinking like final image is forming at uh, infinity, then there will be another formula. So first itself I decided like I'm going to do magnification calculation for when the final image is forming at near point. Then I get the formula for L, that is V naught plus modulus of UE. After that I try to find V naught and UE separately. So how shall I find? So I have magnification formula for compound microscope. M is equal to m naught into me, and I know that my eyepiece will be functioning like a simple microscope. My eyepiece me is equal to 1 plus d by fe. So where I can substitute it 25 and fe value 5, and it will be 30 by 5. I will get 6. Me equals 6, and the final m should be minus. Why the final m should be in minus? In the sense, the final image is inverted, so therefore I don't want to put it as just 30. I want to put it as minus 30. So equals m naught into me. So therefore m naught equals minus 5. And why I am finding m naught and me separately? In the sense, you will understand as the sum goes on. So m naught equals minus 5. Then to find UE, I just use my lens formula. 1 by fe equals 1 by ve minus 1 by ue. And here I told you like I'm going to solve the condition with the condition that final image is forming at a near point. So that's why ve equals, I'm substituting minus 25. Suppose if you are going with d, then you need to substitute only 25 is more than enough. Then here it is 1 by 5, and since ve minus 25, then here minus ue is the thing I want to find. So then rearranging this and finding the value of ue, it is minus 4.17 centimeter. After that, finding it for um, v naught. So since I have my m naught value, magnification m naught equals v naught by u naught, it will be minus 5 equals v naught by u naught, and v naught u naught equals minus v naught divided by 5. And taking this and substituting in my lens formula, so here it will be plus, and it will be 5 by v naught, and now 6 by v naught, and I will get v naught as 7.5 centimeter. And substituting in the main formula, L equals v naught plus ue modulus of ue. I don't want to bring the minus here, so this will be the exact answer, right?